Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm continuing to talk about GMV6 heat recovery, the inside components in the outdoor unit.
This presentation divided into these 4 parts.
Next chapter, we will go to the valves. Four-way valve. In GMV6 heat recovery, in the outdoor unit, there are two four-way valves. This is the cooling four-way valve, and this is the heating four-way valve. And the cooling four-way valve is changed to the direction to accept the low pressure gas from the outdoor unit or from the indoor unit. As for the heating four-way valve, this one, it always conduct the compressor discharge refrigerant to the high pressure valve, offering the heating required. Just like this, it always offer the hot gas from the compressor from here to the high pressure gas pipe. And this is the four-way valve sectional view and also how it operates. And from here you can find that there are 4 pipes. The upper side connect to the compressor discharge called D pipe, and this one connect to the compressor suction side called S pipe, and this connect to the outdoor condenser, we call it C pipe. This connect to the indoor heat exchanger called evaporator E pipe. And from this graph, you can find that it is heating now because the hot gas from the compressor offered to the indoor unit, right? So if this four-way valve would like to change to the cooling, here is how it works, which rely on this pilot valve. Actually, this one is a small size four-way valve. You can find that this one connect to here to get the high pressure, and also this one connect to here to get the low pressure. And we just make the inside small size four-way valve to operate, to push this one, and also conduct the pressure change, to push the most important this one, the slider change direction, and also to conduct the refrigerant to change direction. And here is how it operates when this solenoid valve. Actually, this is the solenoid valve. You can get the power to push the inside small size slider, just like this. And now change from heating to cooling. For the heat recovery, there are 2 four-way valves, and always you can find it here connected with capillary, right? And the purpose of this one is just to release the liquid refrigerant to avoid the liquid hammer, which to release the liquid refrigerant accumulated here, and then release it to the low pressure, which is to the gas liquid separator. You may wonder why there is the liquid refrigerant, right? Actually, from here it is always due to the refrigerant is higher, the temperature is higher than the outdoor ambient, which means it always need to release the heat from gas and become liquid. And if the liquid accumulated here, it will just make this four-way valve to be malfunction, which means if the liquid refrigerant, for example, accumulated here, and this inside slider, it cannot move, and also makes this four-way valve to be malfunction. One-way valve or check valve in GMV6HR located here. And the function of this one is you can lower the start-up pressure difference because we already stopped the discharge, which means we can prevent the refrigerant to backflow into the compressor. And on the other hand, on heating mode, it can also prevent the refrigerant flow, which is from the other compressor from the outdoor unit, and stop from here. in the modular system. And here is the appearance, also with indicated direction. And here is the inside. With this one, we can stop the refrigerant from this side to flow to this one. Only from here, this side, to push this inside spring, and then it can flow to this one. For the installation, when it's upright, and also follow the indicated direction to install. EXV, short for electrical expansion valve. In GMV6 heat recovery, in this diagram you can find that there are actually 4 EXV, which is subcooler EXV, and for the outdoor heat exchanger. For this diagram, we divide it into these 2 passes. So with these 2 passes, we have the corresponding heat tank EXV to control the refrigerant, and also we have a EVI EXV. And this is the sectional view of the EXV. You can find that here is the inside components, and this is the coil where you can get the power, or we input the powers for the coils, then it can generate the force to making the inside pin, which is this one, which connect with the magnet rotor, making it move up and down, and the refrigerant will come from here and flow out from here. They just get expanded at this here, which is this one. You can find that this area is very narrow, which means during installation, the water and the impurities and also the debris, which if you not pay attention that if it get inside into the GMV system, it will also easier to make this to be stung or blockage. And that's why in the system we also have this filter to stop the impurities or water, or even the sorry, not the water, and the debris. Also, you can find here, which is this one, you can find some thread here, right? This is for the dead cake control. And on the PCB, you can find that this is the terminals or the sockets for the EXV. For the heat tank EXV, it has 6 cores, which you can connect this one. And maybe this is a little bit old. For the latest heat recovery PCB, maybe it will be a little bit different. This is the comparison between GMV5HR and GMV6HR. So you can find that first is from the size. This one is GMV5HR. This is GMV6HR. The size, this is actually is generally bigger, and also due to this one, for the system diagram, you can find that for GMV5HR we have this structure. This is just check well bypass with the EXV, right? Do you know why we need to create this one here? The reason it is that in cooling mode, when the system is in high output, which means the compressor in high frequency, at that time the refrigerant flow rate is also quite large, which means here is already become the liquid, and even this EXV is fully open, but for the amount, which is for the refrigerant flow rate, it is not enough. At that time, we need to create this bypass to make the refrigerant to get through this part as soon as possible, as we don't would like to the refrigerant to get expanded here, right? But just compare with GMV6, for this one, it is no need, because it is quite large, which means it is large enough for this size. No need to create the bypass flow. And also due to this one, we don't need to have so much more components, which we can higher the reliability. On the other hand, for the control for this one, it's up to 3000 powers, which we can make the control to be more delicate. On the other hand, for heat recovery, if we separate the outdoor heat exchanger into these two parts, and also we can control the refrigerant only flow from the half of it. And for heat recovery, especially the cooling prevailing and heating prevailing mode, at that time we can make the outdoor heat exchange capacity to be more delicate, in short, more close to the indoor heat exchange capacity, which can especially higher the heat recovery ratio. Solenoid valve. Inside the system diagram, you find that there are lots of the solenoid valve inside, just like this. Its function is to control whether the inside flow, which is the refrigerant or the oil, can get through this valve or not. And this is the appearance. This is how it operates. Always there is indicate direction, just like this. And the working theory is also very easy. Upper side, which is around here, there is a coil. When you get the power, always it will make the inside pin to going up by generate the magnetic force. And then if the pin going up, the inside flow from this A pi will flow to the B pi. Achieve conductive. Filter. Inside the system diagram, also you can find there are lots of the filters. Its functions is also very easy, just to prevent the impurities or the debris getting through. Actually, in our grid design system, when the refrigerant or the fluid will get through the narrow passes, the narrow passes including EXV, solenoid valve, and also the capillary, or when the unit will output or input the flow. Also, we also require to install a piece of the filter. And here is the sectional view. You find that here is the filter core or filter net. It will just block the debris or the impurities here. Unloading valve. There are these two pieces of the unloading valve in this system diagram. Its function is also very easy. You can, from this sectional view, and this is the appearance, you will find that there are two pipes. Inside there is a spring. Here is how it works. When we detect it, the pressure is higher than the force from the spring, which makes this up, and then we will conduct the refrigerant from this pipe to this pipe, which means these two pipes will conduct it. And how we would like to apply this one is, for example, during the storage or the transportation, you will find that from the liquid valve to the inside, which is to this 3, 1, 2, 3, the EXV is fully closed. At that time, the piping inside this part is full of the liquid. If during the storage or the transportation, if the outdoor ambient temperature increase a lot, for example, which 60 degree or 70 degree, at that time, the inside refrigerant also the temperature will increase. As you know that if the temperature increase, also the inside pressure it will increase. At that time, we're just afraid that this EXV is very sensitive to the pressure, which means if the pressure higher than the preset value, then it will make it to be a malfunction, which is broken. Just to prevent this, we apply the unloading valve here. And then if we detected the pressure is higher than the preset value, then we will make it to be conducted, which is this higher, and then conducted the refrigerant to the gas liquid separator, which is the low pressure as it has the large volume. At that time, we can protect this 3 EXV. And also the function is just to release the high pressure to the low pressure area to protect the fragile components like the EXVs. Next, we'll go to the cut-off valve. On side, you will see this picture of the cut-off valve, including this four, which is high pressure gas valve, liquid valve, low pressure gas valve. And this one is the low pressure check valve. For the oil charging valve of JMV5, in JMV6 HR, we make it as a oil charging port located here. That's all for this part of the presentation. If you still have any other question, just feel free to contact me on my personal email address.